Welcome class. Today we will study the fourth colligative property, osmotic pressure. When two solutions having different concentrations are separated by a semi-permeable membrane, the movement of solvent molecules takes place from the solution of low concentration towards the solution of higher concentration. This phenomenon is known as osmosis. Solution of low concentration means there is lesser number of solute particles and more number of solvent particles. So, due to concentration difference, there develops a pressure difference between these two solutions, and due to this pressure difference, movement of solvent molecules takes place from low concentration solution to high concentration solution. Or we can say that from the solution having more free energy towards the solution having less free energy. Or it may also be defined as the movement of solvent molecules from the solution having high chemical potential to the solution having low chemical potential. Or it may also be defined as the movement of solvent molecules from solution having low osmotic pressure to the solution having high osmotic pressure through semi-permeable membrane. So all these phenomena are termed as osmosis. देखिए यहाँ पे solvent molecules का movement लो कॉन्सेंट्रेशन ऑफ सॉल्यूशन से हाई कॉन्सेंट्रेशन ऑफ सॉल्यूशंस की तरफ होगा. लो कॉन्सेंट्रेशन सॉल्यूशंस का मतलब जहाँ पे सॉल्यूट की मात्रा कम हो और सॉल्वेंट की मात्रा ज़्यादा हो. तो सॉल्वेंट की मात्रा ज़्यादा होने का मतलब है कि जहाँ पे वाटर का लेवल ज़्यादा होगा, वाटर का कॉन्सेंट्रेशन ज़्यादा होगा, सॉल्वेंट का कॉन्सेंट्रेशन ज़्यादा होगा, वहाँ से लेस कॉन्सेंट्रेशन की तरफ वाटर का मूवमेंट होगा थ्रू सेमी परमेबल मेम्ब्रेन, और इसी फिनोमिनन को हम लोग ऑस्मोसिस कहते हैं. And this movement of solvent molecules takes place until the equilibrium is reached, or we can say it when the concentrations towards the both side becomes equal. ये movement तब तक होता रहेगा जब तक कि equilibrium की condition नहीं आ जाती, यानी दोनों तरफ concentrations बराबर नहीं हो जाते, दोनों तरफ solute का concentration और solvent concentrations बराबर नहीं हो जाते. So this phenomenon is known as osmosis. Now during this movement of solvent molecules, or during the process of osmosis, we see an external pressure is applied towards the solution side, which tends to prevent the flow of solvent molecules, or which tends to prevent the process of osmosis. अब इस phenomenon के दौरान solution side से एक external pressure apply होता है जो सॉल्वेंट के फ्लो को प्रिवेंट करने की कोशिश करता है, इस ऑस्मोसिस प्रोसेस को प्रिवेंट करने की कोशिश करता है. एक तरह का ये हाइड्रोस्टैटिक प्रेशर है, क्योंकि जैसे जैसे सॉल्वेंट मॉलिक्यूल्स का मूवमेंट लो कॉन्सेंट्रेशन से हाई कॉन्सेंट्रेशन की तरफ होगा, तो दूसरी तरफ क्योंकि सॉल्वेंट का कॉन्सेंट्रेशन बढ़ेगा तो वो इस फ्लो को प्रिवेंट करने की कोशिश करेगा. तो ये जो प्रेशर डेवलप हो रहा है अपोजिट साइड में, जो सॉल्वेंट मॉलिक्यूल्स के मूवमेंट को प्रिवेंट करने की कोशिश कर रहा है, जो प्रोसेस ऑफ ऑस्मोसिस को रोकने की कोशिश कर रहा है, इस प्रेशर को हम लोग कहते हैं ऑस्मोटिक प्रेशर. So the external pressure which must be applied on the solution in order to stop the flow of solvent into the solution through semi-permeable membrane is termed as osmotic pressure. Or we can say that the hydrostatic pressure developed as a result of osmosis is known as osmotic pressure. And osmotic pressure, they are measured in terms of hydrostatic pressure. That is, the hydrostatic pressure developed during the process of osmosis is a measure of osmotic pressure of the solution, and is defined as the pressure built up on the solution which just stops the process of osmosis. देखिए आपको डायग्राम में देखिए आपको दिख रहा है कि जैसे जैसे वाटर का लेवल बढ़ रहा है फनल में, वैसे वैसे क्या हो रहा है कि यहाँ पे एक हाइड्रोस्टैटिक प्रेशर भी लग रहा है जो डाउनवर्ड है, और इक्विलिब्रियम कंडीशंस में हमें दिख रहा है क्या कि द मैग्नीट्यूड ऑफ ऑस्मोटिक प्रेशर इज इक्वल टू द मैग्नीट्यूड ऑफ हाइड्रोस्टैटिक प्रेशर, एंड दिस हाइड्रोस्टैटिक प्रेशर इज इक्वल टू h rho g. So we can say that the osmotic pressure pi is equal to h rho g. So this is osmotic pressure. So this osmotic pressure is due to the concentration difference, or we can say it is due to the difference in number of solute particles. That's why this property, that is osmotic pressure, is considered as a colligative property. That is, it depends upon the number of solute particles, it depends upon the quantity of solute particles. Now see some laws of osmotic pressure. See Boyle's Van-'t-Hoff law. According to this law, osmotic pressure is directly proportional to concentration at constant temperature. And concentration is molar concentration, that is, it is equal to number of moles upon volume of solution in liter. So we can say that osmotic pressure, it is inversely proportional to volume, or pi v is equal to constant. Second, Charles Fonsoff law. According to this law, osmotic pressure, that is pi, is directly proportional to temperature at constant concentration, or pi upon T is equal to constant. Next, Avogadro's Fonsoff law. According to this law, osmotic pressure is directly proportional to the number of moles at constant temperature and at equal volumes. On combining above three laws, we get pi v is equal to nRT, or pi is equal to n upon v RT. N upon v is concentration, so pi is equal to CRT. When the concentration is equal to number of moles per liter of volume, so it is equal to molarity. So we can say that pi is equal to molarity into gas constant into temperature. Or we can say that here the osmotic pressure is directly proportional to molarity, and that's why it is considered as a colligative property. Earlier we have studied that colligative properties are directly proportional to molarity. But in case of very dilute solutions, the magnitude of molality is equal to the magnitude of molarity. So we can say that here the osmotic pressure is a colligative property. It depends upon the molarity of the solution, because the molarity expresses the concentration of solutions. It expresses the number of solute particles in any solution. So colligative property, that is the osmotic pressure, is considered as a colligative property. Next, with the help of this formula, we can calculate the molar mass of the solute. See here, pi is equal to CRT, or C may be written as N upon V, that is number of moles upon volume of solution in liter, into RT, or pi is equal to number of moles of solute may be written as mass of solute upon molar mass of solute, and this is equal to pi is equal to M upon M, that is molar mass upon molar mass, into RT upon V. And from here we can calculate the molar mass of solute, that is capital M is equal to small m upon pi, means mass of solute in gram, upon osmotic pressure into RT upon V. Now see here, if the value of R, it is taken in liter atmosphere per mole per Kelvin, then the pi will be in atmosphere, and if the unit of R will be in joule per mole per Kelvin, then the unit of osmotic pressure will be in the Pascal or the Newton per meter square. So this is all about the osmosis and osmotic pressure.